Hello everyone. I hope you are now a bit familiar with web components and how they work with using vanilla JS. And I saw that you are already curious about how we can implement them with React. So in this presentation, basically I'm gonna talk how we can build the same counter application that Philip did by using the React library. So before we go with the content, my name is Dan and I'm JavaScript engineer that's working at Infinum Skopje office, and I mainly focused on developing React applications. So the content that we are gonna cover is why using React, how we can define React web component, how we can attach a shadow DOM tree to it, add some styles, create slots and use them, and create custom events for communication, and of course in the end we will have a Q&A session. So before we go with the demonstrations, we will see why we are using React instead of React and what are the benefits. But well, since we are using web components that we'll be mainly using within a context of a different DOM, and there are some advantages of choosing React. Some of them are like size. Its small size makes it easily to distribute and reuse in different contexts. Its smaller footprint can be a significant advantage when it comes to project resource constraints such as limited memory or processing power. Is designed to be highly compatible with React. So if you're already familiar with React, transitioning to React can be relatively straightforward because the APIs and the concepts are very similar. Also, you can alias React with React, and by that you can ensure that some third-party libraries that are using React can also work as expected with React. Also, you can maintain compatibility between your React-based code and React-based code, and by aliasing, you can ensure that both libraries can coexist together peacefully. And also, if you are already using a large React code base, you can easily migrate to React by aliasing. So enough about React, and let's see through the demo how we can create our first React web component. So I've created here some React application that is created to npm create void and React library with TypeScript programming language. And here, if you might already be familiar with the structure, we have the index tsx script from where we have the React renderer, which is basically trying to render our React component within the document element that have ID of app, which is within our index HTML, and from there React will pick up our component and mount it on its place. And if you go in the counter component, we will see that we have some simple counter component that is basically receiving min and count probes, which are setting our current state, and we have some functions like increment and decrement, which are handling our action changes for the buttons that we will have for incrementing and decrementing the counter, which will be displaying it within the spam element. And that's basically our counter that we have within React. And if we go to our server, we'll see that we have our counter, which is increasing and decreasing. And how we can do this and have this counter within our web component, our custom element that we're gonna create? Well, basically, if you go in the index tsx, if you are following Voska, you will see that we will need to have a class, our custom class, that will extend the HTML element class, and within there we will have our mount point, which will now our mount point instead of the app ID for the element we have. And from there we have the constructor, which is calling super in order to correct prototype chain be established. And we have the connected callback function, which is basically calling once our web component is mounted to the DOM, and from there we will create an element of type div, and we will add it to our mount point, and from there on our web component we will append that element, and we'll call the mount function, which is basically checking if we have defined our mount point, and from there we'll use now our Preact renderer, which will render our Preact component within the mount point we had created. And we also have the observed attributes array that should observe for the attributes we want to define in the array, and the attribute change callback, which will detect those changes, and you can do some logic there once your attributes are being changed to the web component. And from there we also call the mount function in order to render our component with the updated values. So disconnected callback will basically be called once our web component is unmounted from the DOM. So in order to define these custom elements, we need to call the window global browsing context, which will call the custom elements registry interface, from where define method will be called, and we will create basically a custom element within the global browsing context. And before we create it, we need to make sure that such an element doesn't already exist. And if we save this and we go to our browser, nothing has shown. So why is that? Because we have an div with id app, but we didn't use now our web component within the index HTML. So we need to go there and use our custom element. So we need to say Preact counter, and if we go now, we'll see that we'll have also the Preact component and also our custom web component rendered to the DOM. And if we inspect, we'll see that we have our custom web component here, and we can also pass some attributes to our web components, like min of 5 and let's say initial of 10. So from there we can get those attributes through the this get attributes, and we will parse them and we will send them to the counter Preact component. So if we see now, we see that we have our web component that is using Preact. So yeah, that's how you can define and how you can use your Preact web component. Yeah, as we mentioned before, we have our web component, but it's good to attach a shadow DOM to it, so we will not affect, or our elements will not be affected, or we should prevent some style leaks from outside of our DOM, and vice versa. We need also to prevent events happening from our web component to interact with the outer DOM, and vice versa. And also we would reduce some risk of malicious code interfering with our web component. So let's go back to the demonstration and web component. So as we said, the connected callback will mount our web component, and this is the place when we need to attach a shadow to our web component with mode to open. And since we have attached our shadow DOM, we will attach our to its shadow root our mount point. This means that our mount point will be now within the shadow root, and from there we will not need to append it to our web component. And if we inspect now see our browser, we will remove this for now, and if you see now our browser, we will see that our web component now is having encapsulated shadow root, and from there we will see that we are using shadow root now, but if you may see that we lost some styles here, and that's basically what we wanted to achieve, since the Preact by default the imported styles we have for the component is basically appending it to the head, which is outside of our shadow root, and that means that styles outside our shadow root cannot be applied to our elements within our shadow root. So let's go back to the presentation, and can add some styles now with the style attribute, with a global style within the shadow DOM, and also there is a way how we can import some styles inline the web, our web component. So also someone might ask, what about external styles, and how we can let the users add some external styles to certain parts of our web component? Well, we can use that by using the part pseudo element, and by exposing those parts to the part pseudo selector, we can allow users or other developers to customize the appearance of our web component. For example, a button component might expose parts like label, icon, or background. We should enable users to style those parts according to their design requirements or team preferences. So let's go to our demonstration and see how we can actually add those. The first thing that we would see how we can add global styles to our shadow DOM. Well, once we've created our shadow root, we can add styles there through the creating a style element and adding a text content with it. And basically by adding a text content and adding that style to our shadow root, we can see that if we open our server now, we will see that the style that we defined for our class counter is applied now to the span that is showing our current state, and that's because we've added those styles within our shadow root. But what about the other styles that are still within our head and they are imported from CSS files? Well, if we go to our counter component, we can basically add also these styles through the style tag, and we can import them, for example, like this with the inline module. And this is basically giving our CSS files in a string representation, which we can use within our Preact component and add them here. So basically what this is gonna make, once our web component is rendered to the DOM, our styles will be added inline and it will be present inside our shadow root. And if we go to our browser now, we will see that within our counter container we have those styles added there. So that's basically the other way how you can import and add styles to your web components. And yeah, also we said that we want to enable some parts of our web component to be styled from our external DOM. How we can do that? We can do that by specifying, for example, on the button a part attribute with name. Let's say this is the crease button, and let's say we would like to also enable users to style our increase button. So if we go to our index HTML now, users that are going to use our web application can add a styles, and those styles need to contain the name of our custom element and the part pseudo selector and the name or the name attribute that we have defined for the part that we want to be styled from the outside of the world. And if we go now, we see that those buttons are being styled from the Preact counterpart, which is basically outside of our shadow DOM, and those styles are applied to the parts that we enabled users to style them. So yeah, that's basically another also good thing to know. And let's discuss and what are they, or as I usually want to call them, a web component placeholders. Well, so to enable users to enter a specific content into predefined areas within our web component, and this allows our web component to be used with different content, enhancing code reusability and reducing redundancy. Open my slots and let's go to our index HTML. If you can see there that we have defined some content within our custom element or web component, and that content is basically saying that our count is of 10 and min of 5, and maybe the users wants to use that content and display it somewhere within our web component. Well, we can allow them to have that by defining the element slot, for example. And if we define a slot, let me open the server, we will see that this slot, it doesn't look that nice. Let's have it outside of our, yeah. And if we see that this content that was defined within our web component is basically displayed in the place or revealed when we define that we want to show that content that the user will have within our web component. And this is basically called a default slot, and any content that users have within our web component will be displayed in the place where we defined that we want it to display. And also you may have multiple slots, not just a default slot, and by having multiple slots you can define them with the name attribute and have them, let's say, deal with this will be description slot, and let's have another slot that will be some header, let's say. And having these slots, user can now set some content to our web component by defining the slot name that we provided, and this will be, for example, let's say description, and let's say we have some heading h3 with slot name header as we defined, and let's say react counter web component. Okay, and if we go to the browser now, we will see that this slot with the name with slot header is placed in our slot with name header, and the other slot with description is placed in the slot with name description. So that's basically how you can let the user enter some content within your web component. Let's see what are custom events, and at some point we would like to communicate with the outside world. So user who is using our web component for some specific actions or reason they want to notify us, or we want to notify them about something's happening or some state is changing. So we can use that through defining and dispatching custom events, and by defining custom events we can expose a set of meaningful events that represents actions and interactions happening with the component. We can also send custom payloads to our dispatch events, which even makes more informative and useful for users that are going to receive them, and anyone using our web component can listen for those custom events by using the standard techniques such as adding event listeners to our web component or to our custom element. So let's go to our demo and see how we can dispatch those events and how the user can basically listen those events and do something with it. Let's go to our counter component, and from there, as you can see, I've created some reference that is referencing to our counter container wrapper, and from there basically I am dispatching an event which is a new custom event with name of counter change, which is set to bubbles true, which will propagate through the root, can be cancelable, and we had set some detail about the next count value that is going to be set to our state, and also I have same event happening for next count state that is going to happen once we decrement our state. So how the user can listen to these actions. Well, he can basically add or query selector our web component and add a listener to it with the same name that we dispatch an event, and from there he can do something like, for example, now what we did, we are getting our slot with ID slot 1, and we log our new state that is happening when we are incrementing or decrementing, and we will also console log for that some event has happened and what is the value that we will receive. And if we go to our browser and let's go to our console, and well, nothing's happening, so maybe someone knows why it's that. Well, basically right now we are dispatching an event within our shadow root, which means that it will not propagate outside of our shadow root, and that's the case we want to cover, and we basically want such an event to propagate outside of our shadow root in order the users that are using our web component can receive them. And how we can do that? Well, if you go in index.tsx and when we have mounted our preact web components, we can simply pass our shadow root to our counter component, and from there we can use the shadow root host, which will basically dispatch events through our web component, or the host, which is our web component. So if we do it like this, we'll see that the events are dispatched through our web component, and the users that had added a custom event listener to our web component will receive such an event. So yeah, that's basically it. So, there are some resources you can check, and also if you have any questions, feel free to ask.
So maybe I understand the communication between the web component and the rest of the application with creating this event. Is it both ways? Can we track for a change in the main application that will...
Yeah, that's basically actually a good question. I will let my colleague who have the next presentation. He'll explain something that our client wanted, and we achieved that, like having some kind of both communication up and down, and you can actually see, you can have something like that, yeah.
Okay, and one like a stupid question, but having same IDs in the shadow root and in the outer part of the application, will it cause some conflict, or it's isolated?
I'm sorry, having what?
Having same ID for some element. How will this...
Same ID within...
Same ID on some element. Let's say you have ID home in the main application and ID home in the shadow root. Will this...
No.
They are separate?
Yeah, they are separate.
Okay.
Yeah.
Is this compatible with Redux and our generalized?
Yeah, sure one. You can use Redux within your project for state management or other third-party libraries.
Is there some framework like a compiler that will have this manual traffic to a customer?
I'm not sure about it.
Not to do that part,
Yeah, I understand, but I'm not sure that we have some.
Transfer to the other code.
Yeah.
Thank you.
Yeah, that's,